Okay, so first I'm going to start with SolidWorks. And if anybody's watching like videos online or streaming anything, please turn it off because I'm doing the remote connection to SolidWorks. So if you guys are bogging down the internet, it's not going to work for me. All right. So if you're watching videos or playing video games, let's not do that now. All right. So I'm just going to make a beam in SolidWorks. All right. So yeah, I'm just going to make some sort of a fancy sketch in the front plane here. So I guess this will be a beam with like 2 holes or something like that in it. And I'm going to make it asymmetric so these are different sizes. So you guys are all familiar with SolidWorks, right? So I don't need to be explaining like the steps I'm doing or anything like that? All right. So okay, so I made this sort of fancy geometry really quickly in SolidWorks. And in Patran, you could still do this in Patran, but it'll just take you a little longer. So that's the benefit of doing it in SolidWorks. And now I'm just going to extrude it. And how long do you guys want me to make it?
12 feet.
12 feet? Yeah, but that'll probably be a little much. What?
2.
2? All right. All right, so we got this thing. All right. Now the key to exporting from SolidWorks is when you go to Save As, right here, you want to select the IGS part. Where is it? Right here. IGS. And if you could export it just like the way it is, and it'll export as a bunch of surfaces and lines. But those are going to be a little hard to work with in Patran. So what you got to do is go to Options, and right here, on mine it's already set to solid, but on most everyone else's it'll be set to bounded surface. So make sure to set this to solid. And that way it'll actually export as a solid thing that you could use directly in Patran without having to make any other changes to it. All right, so let me just save this to my desktop. Ah, come on. Sorry. And here it's, if you have a part that's made of several things, you could export them individually by doing selected bodies. I'm just going to, since I have one part, I'm just going to do all bodies. All right, so now we're done with SolidWorks, and we created this IGS file right here. Now we could go back into Patran. In Patran, we want to create a new database since we're starting a new project. And let me just call this something like, all right. And the only thing you have to do to import this guy is go to File, Import. Here we are selecting the type of thing that we want to import. So we want to import the IGS file. And so I selected IGS here in source. And now the thing you want to always turn off is this import as parasolid, because that's a little more advanced and I haven't been able to get it to work very well. So it works just fine without it. So make sure to uncheck import parasolid. And then here you could find the file that you want to import. and gives you a summary of all the things that you're importing. Now for your projects, you want to make sure that this quantity says 1 right here. If it says anything other than 1, then the thing you built in SolidWorks is like 2 separate things that got saved as 2 separate solids. So you want to make sure that whatever you build in SolidWorks is 1 solid, otherwise it's really hard to do an analysis on it. So just make sure this quantity is set to 1 right here. And if it's not, then you got to go back to SolidWorks and make sure that your whatever model is exactly the way you want it if you didn't create some other thing somehow on accident. Okay, so here's this. And right now it looks 2D, but you have your controls here in Patran that'll let you view it under a different direction. So here's this. Let's see, how do I zoom? Sorry, my bad. Got to remember how to zoom. How do I zoom? Oh, wait, hold on. It's like, yeah. There's a keyboard shortcut to it. Hold on. Let me. I was doing it this weekend and I forgot the keys again. Okay, well, all right, forget that. All right, let's just do this. So there's a really cool zooming thing, if I could ever remember how to do it. Oh, here it is. All right, so you hold down Control and the middle mouse button, and it lets you zoom with your mouse. And this is way more convenient than using the zoom button right here, because the zoom button sometimes causes your view to glitch, and then you have to refresh your view by hitting this refresh graphics button. So I would recommend doing the Control plus middle mouse button to and moving the mouse back and forward to zoom. It just works a lot better this way. So let's make this thing solid. So here we have our part. And okay, so now in order to run the analysis on it, we're going to have to tell it what it's made of, what the forces on it are, and where it's anchored. Yes.
So does that mean that if you were to put material properties in through SolidWorks, it wouldn't?
No, it wouldn't. IGS, I'm pretty sure IGS doesn't bring material properties through.
Physical model.
Yeah. You might be able to do it somehow. I didn't want to play with it too much because I would just rather do it through Patran because then I know exactly what I'm telling it. In SolidWorks, you have to assume that the export is going to keep everything exactly the way you want, like the units and stuff like that. Because one of the big things in Patran is it doesn't have units, so you have to make sure to keep all of your own units. So if you rely on SolidWorks, it might be different from what you expected. Yeah. All right. Okay, so first we're going to go to, so we already did all the geometry stuff. That was the importing, so we get to skip the geometry tab. Now here in the properties tab, we can do sort of isotropic. And for adding a new material, you want to give it a name. So I don't know. Yeah, something like that. And now you're going to give it properties. What do you guys want me to give it as an elastic modulus? 3? 3? Okay, let's do 3 to some power. 3, I don't know, 10? All right, that's good. Poisson's ratio, all right, let's do something. What? Oh, okay. Well, what else? All right, just something. All right, so now this thing's got its properties, and we don't need to change any of the other settings, so we hit apply. And now my steel is listed in the existing materials. So when we go to solid, and here we give it a property set name. So just call it set1 or something like that. Here, when we select input properties, and we click on this little material icon in the corner, my steel is actually going to be listed here. So we can just click that. It automatically imports all the right settings. And just OK. So now we select the application region. We want to apply this to the solid. Now, there are several ways of selecting things. You could actually click on your part to select it. But sometimes, depending on what other settings you've been clicking around, it's not going to let you select the part. It's going to make you select the face or something like that. So what you want to do is right here in this little vertical bar, make sure that it's set to solid right here. So just click on the solid before you select anything. And now when you click on your part, it'll actually select it. And it'll be listed here as selected members solid 1. So we hit add. Now it's added to it. And then we hit apply, and we see that the set that we just typed appears here in the existing sets. All right. So that was applying properties to it. Now we can apply our loads and boundary conditions. So when I was building this, I was just assuming that one face was going to be at a wall or something like that. So let's rotate this. And I'm rotating by holding down the middle mouse button and dragging my mouse. So we're going to just constrain this. And we're going to say that the translation is going to be fixed. So it's going to translate 0, 0 in each direction. And I don't want it to rotate either. So 0. So both the translation and the rotation are going to be fixed. And we select the application region. Now here again, like I was saying before, you want to make sure that you're set to the right selection. Like I don't want to be set to a point because I want to actually get the whole wall to be selected. So I'm going to select the surface. And, whoops, no, not that. This one here, surface. And so now I can actually select the face. So, what you notice here is this saying, it still says solid, but it does 1.2. And what it does is the first number is the solid that you want, then the point is the face on the solid, and then if you have another point after that, it's an edge, another point after that, it'll be a point. It'll actually be a point. So like if I did 2.1, that'll be the first edge on the second face, and so on and so forth. But right now we just want the face, so that's why it's 1.2 right here. So we add that, and so now it's saying that the second edge on the first solid is where it's attached at. Okay, and we hit apply. So now we have our little force, our little constraint indicators here. And I want to apply a force. And for this force, I'm going to apply it to this inner ring right here, to the edge of the inner ring. So, and let's say, how much do you guys want the force to be? $1 million. $1 million? Okay, let's do $1 million. Might be a little excessive, but okay. Yeah, that might be a little too much. All right, let's go for 100,000. Or whatever I just typed. Okay, so select the application region. And here, I don't want to apply it to a face like I was saying before. I want to apply it to just that edge of that circle. So I'm going to select this curve or edge, and it's going to allow me to apply it to this edge. And see, it says solid 1 here. So I'm going to apply that. And I'm also going to apply it to this bottom edge of this circle as well. So it will be applied at 2 places. So now you notice it's solid 1.6.1, so that's on the 6th face of the solid on the first edge, and then on the 8th face of the solid on the first edge. All right, so now this is applied, here's apply, and now we have our 2 forces that are going in the x direction. All right, so the next thing you want to do after that is, since SolidWorks doesn't bring in any of its own meshes or anything like that, it just gives you that geometry, you're going to have to create your own mesh. What I would recommend when you're working with SolidWorks parts is actually doing some of these advanced meshing like uniform and one-way bias and stuff like that. But I don't want to spend too much time on that today because you guys will be having that on Friday. So I'm just going to make just a basic mesh right now because these can take a little while to get it exactly right because you might go over 5,000 elements and whatnot. And it's just kind of tedious. So I'm just going to create a basic one here in the solid. So we can set this down to TED4. It doesn't really matter. It's a little easier this way. So here I'm going to, for the parts, I'm going to select the solid. So just grab the whole solid. And here is where I get to play with the mesh size. So I'm going to turn off the automatic calculation, and I'm going to turn down the element size a little bit smaller, just so we can get smaller elements. So I'm going to try to get as close to 5,000 as I can. So let's just do 0.5 for now. All right, and apply. So now it's going to work for a little bit. And right here, we can't really see anything because it's all purpled out, but you could hit the refresh graphics so that you can actually see what it looks like. So this looks pretty nice. It's got very nice fine mesh here, but the elements went over 5,000. And the way I know that is because the node tells you what the next node that you're going to put in. So if the next node that you're going to put in is 5,943, then it means that you already have more than 5,000 nodes. So I'm going to change this number right here to something like 7, and then hit apply again. And it's going to ask me about overwriting. And so this still looks okay, but our element size is under 5,000. So I'm going to try to get a little bit closer, but I won't play around with it too much. All right. List all. And refresh the graphics again. Yeah, so, well, it's closer. Not too close, but oh well, this is good enough for our analysis. You guys can play with that number and try to get a little closer, but I would honestly recommend for your projects using these directional bias things, which are going to go over on Friday. So now that you have everything meshed and imported and stuff, you could go to analysis, and we want to do an analysis of the entire model. So select entire model, and here you can give it a job name. I don't know. Ooh, class project, cool. Oh, and one thing to note is you notice I don't put any spaces in any of the names I use. That's generally better for Patran. I think you can do it in some places and you can't do it in other places, so I just say just don't put spaces anywhere. And you could put like an underscore or whatever if you really need a space. So the things you want to do in this analysis is you want to make sure that your solution type is linear static. And for subcases, you want to make sure that you have output requests set to output displacement data, stress data, and I guess the forces are also important. So the way I got to that was going to select I went to subcases, and then in subcases I went to output requests to get to this menu. And if something that you want isn't listed here, you can select it from the menu on top right here. Okay? So everything is already set for me the way I want it, so I can just hit apply, and Patran will run this analysis. Hopefully nothing will crash. All right, looks like it's done. All right, so the next thing we want to do after that is we want to view our results, and so in order to do that, we need to attach the XDB, which is the database. So here we go to database, and here we have our job name, class project. So that's what we want. If you were running several jobs, you'd be able to choose from different ones here. Also, if your project, when I was taking this class, I had my project crash several times, and I tried to create a new database for it. I tried to just run the analysis over and over and over again under different names, and eventually I got cluttered with a bunch of projects here, and nothing would work. So what I had to do is I went to, instead of access results, I went to delete, and I was able to delete all of the useless ones, and then I just made a clean, fresh one, and it worked after that. So if you're working on something and it just doesn't seem to work and you have a bunch of jobs here already, just go to the delete button, which I got through going to the action menu, delete, and just delete all of your old runs and just make a fresh one. So you don't have to like start your whole project over again, you could just start the analysis over. So that'll probably save you some time. Okay, so I already applied the, oh, I'm sorry, no, hit apply. Yeah. Oh, whoops, that was the analyze. I thought it was in XDB. All right, well, this will only take a minute. So I just ran this thing twice, but it should be fine. So go to XDB and then hit apply. All right, so now all of our results are attached, and we can go to the results tab and we can view our deformations. All right, now I'm going to show you some like graphics things to make your results look better. But first, before I do that, let's just look at the displacement translation. So we select displacement here, and we select the displacement right here, and hit apply. And we see that this thing got displaced. But what you notice is that the old shape is here, and it's really in the way. It's really hard to see what's happening there because of the old shape still being in that spot. So what you can actually do is go to this guy right here, fringe attributes, I believe. Let's see. Yes, this is the right one. Or wait, no, is this the right? No, I'm sorry. It's this one. Yeah, okay, here it is. So you go to this third guy right here, deformation attributes. And what you can do is uncheck this that says show undeformed. And so now when you refresh the view, refresh graphics. Oh, whoops, thank you. Yes, hit apply. Hit apply, and you notice the mesh disappeared. But the part still looks like it's there, and you're like, well, didn't I just turn off the show undeformed, so why is it still there? That's actually your original model. So to get that to disappear, you can go back to home and hit the wireframe button. So now if you refresh the view again, I'm sorry, you got to hit apply again. Hit apply. Now, instead of having that big clunky model there, all you have is this thin outline of it. So it's much easier to see your deformation results this way. And this might be useful for generating pictures during your project, just so it's not so in the way. Now, one of the other problems that you might have is this blue right here is the same color as your background. So we want to change our background color to make it display better on when we take screenshots of this. So you could do that by going to display. Where was I doing this yesterday? Oh, I'm sorry, viewing. Oh yeah, I'm sorry. It's under preferences, graphics, and then here you can choose the background color, the viewport color. So you can set it to white, hit apply. And I can't really see the forces on it, so this might not be the best option. But you could play around with different colors that'll allow you to see the colors better. So like this black one looks good. So that's that. Let's see. One of the other things that you'll probably want to look at. Oh, by the way, to go back to your results and see other results, it's you know how I was hitting the right button here to change this so that it's not visible? If you click the left one here, select results, it lets you show other results. So let's go to stresses, and we can choose von Mises, and hit apply. And now we can see the stresses. Now, and of course you could zoom in on here and look at the stresses right here where the force is actually being applied inside these channels. But one of the things you might notice that I did that was weird is I kept this at displacement translational, even though I did this as stress. The bottom box here is actually the way it displays your information. So it displays the stresses by how much this overlaid on top of how much this thing has displaced. If I actually change this to like forces, it'll look really weird. So you see, it'll display the deformation in this thing like by the magnitude of the force. So this is not what's happening at all physically. This is just representing the magnitude of the force, and it's really hard to see that. So you always, it's really hard to visualize what's going on there because of that. So you always want to keep the bottom box on displacement translational, because that way you can see how it's deforming, and then the colors are coming from this box up here. So whether we have it set to stress or we can set it to displacement. So those are just the top boxes for the colors, the bottom boxes for how the part is actually deformed visually. And I'm pretty sure that was actually all that I really wanted to talk about. That went a lot faster than I intended it to go. I guess I was talking too fast. But if you guys have any questions about this, I could like do other models or anything like that if you want. Yeah.
Remember in the beginning, I was having trouble following how part was exporting from SolidWorks into Patran and making sure that the quantity, I guess, stays down.
Yeah. Okay. So when you're building a model in SolidWorks, one of the things that you can do, let me go back to the sketch. Okay. So you know how I made the sketch right here? If I made another element here on the side, and I'm not even going to bother about dimensioning it and stuff. So here's this thing, and now I have two parts to it that got extruded. If I export this, this will actually get exported as two separate solids. So when you import it into Patran, that number that I was talking about is going to be set to 2. So now this is obviously two things, and you can very clearly see that. But sometimes when you're working on a really complicated part, the other component of it that could be screwing you off, that might be throwing you off, is it might be a really tiny thing in the corner. Like I don't know if you guys remember in the actual SolidWorks class that we had, there was a particular model for one of the homework assignments that we did, where it's like several circles coming together, and it looked like it worked perfectly, but because of the dimensions that he gave you, there was actually one little tiny piece that was still sticking out, and you had to zoom in really, really close in order to be able to see it. So if you go and import your model into Patran and it says 2 on there or instead of 1, then that'll be something to look out for. And I'll show you how it does that in just a second. So let's save this. So we'll go to Save As, and here we select IGS again. And here, let me just call this part 2. And it obviously didn't type. Okay, so now again, we got to go to options and make sure this is set to solid here. Now when we hit save, it was in your save dialog box. There's a big box called options, a big button called options. Go into there and you'll have a setting in there that says you're exporting as a surface. Make sure to set that to solid.
Manifold solids?
Yeah. Okay, so I just exported this. Let's see. All right, here's my part2.igs. So now when we're imported into Patran, let me just start a new project. Actually, no, I think I can just, all right. So this is a good time to show another cool trick. So if you want to delete stuff, you could go to the thing that you want to delete. Like for example, we want to delete the mesh. You could go to, instead of create, so I'm in the mesh tab right now. Instead of create, I'm just going to set it to delete. And just select this whole thing and delete everything. And now I can go back to geometry. I want to delete the geometry. So again, in here in the action, I select delete. Select the whole thing and delete it. All right. And I'm going to refresh the view so everything goes away. All right, so now everything is gone. And we can go back to File, Import. Here in Import, we select IGS as the thing that we want to import. We make sure to uncheck the Import Parasolid. So you see this checkbox that says Import Parasolid. Make sure to uncheck that. And now let's select our part. Okay, and here, when we imported it, you notice it says 2. Right here, in the box right here in the quantity, it says 2. So if it says 2, you probably have something in your geometry in SolidWorks that's not exactly correct. Unless you actually intend to import 2 parts, in which case the analysis is a little bit more complicated. But I'm not going to do that now. Okay, so you see that both of these are imported. And I guess I could show you what happens if you do analysis on these 2 parts. So it looks like all the forces are still there, which is weird, but okay. Let me apply some loads to this thing as well. Displacement constraint. Application region. I want to apply this right here. Face. Okay, and the force. You know what? These 2 parts are probably too far away from each other to show you what I wanted to show. But I'll still run the analysis anyway, just so you could see it. Well, what I actually wanted to show you was that if the 2 parts are close to each other, and you're thinking that one part is going to push on the other part, it's not going to do that. There is no collision detection, at least as far as I know of in SolidWorks. So if you build something with 2 parts in it, and you're like, well, when one of them deforms, it's going to push on the other part, it's not going to happen because you don't have collision detection. And so unfortunately, I drew this too far away from each other, so you're probably not going to be able to see it anyways. But let's just run this and see if we can get something to happen. All right, so okay.
When you import the model,
Yeah.
there's a little box that says import Parasolid. Does that mean you check that?
Uncheck that. If you do it, it causes it to crash. I've never been able to figure out a way to actually do it with that thing turned on. All right, so now I meshed both of these 2 things, and I'm going to go to analysis, run it. And while it's running, one thing to note is looks like it crashed. All right, we'll see what happens. But one thing to note is, you know how before importing this new model, I did 2 things. I first deleted the mesh, and then I deleted the solid. You always want to do that first. So like the way you're building things is you build solid, forces, mesh. So when you're deleting something, you always want to go the opposite way. First you delete the mesh, then your forces, then your solid. And I actually forgot to delete the forces, but I think it's okay because I just applied the same exact forces, so it should be fine. But it would be better if you do delete mesh, delete forces, then delete solid, instead of deleting the solid first and then you can't delete anything else because it's just floating somewhere in your computer's memory and you don't know where exactly it is. All right, so that's done. So now XDB, apply, results, deformation. Oh, look, it didn't work. All right, so yeah, this thing crashed. Well, anyways, yeah, it crashed because I don't have any results in here. So, but the point is, if you were able to get this 2-body thing to work, you would see that one of them deforms, and even if it hits the other one doesn't deform because it doesn't have collision detection. Let me see if I can actually fix that problem with the results not showing up. So let's go to delete the existing job. All right, and let's apply the analysis again. All right, let's see if it works. If it doesn't work this time, then it's because I didn't delete those forces when I was deleting everything else. And judging by the black screen, it's probably not going to work. Okay, let's go to XDB, attach the XDB again. Results. Nope, no results. So if you don't have results, it's because when I was deleting it, I didn't delete those forces, so now it's just screwing everything up. But yeah, the point is, if you have two objects, it makes things a lot hairier, so make sure you always have one object, unless you really, really need to have two objects. All right? So does anyone want me to show anything else while I'm here? Nope. All right, well, that was pretty much everything I wanted to talk about. So Professor Chan, I guess I'll turn this over back to you. I already went through everything I want to talk about. Yeah. Any other questions? Okay, yeah.
I guess that means that assemblies are completely out, right? You cannot analyze assemblies?
Yeah, you can. It's just really hard. You'd probably want to consult Google for that on how the right way to do it. Because the problem is I haven't been able to figure out how to do collision detection in here. So whenever I have two models, like if I deform one of them, it just goes straight through the other one. And it just like, it doesn't even know it's there.
Okay.
So, yeah. Yeah.
Can you show us how to do our second homework problem?
I'm not a TA for this class, so I don't actually know what your homework problems are. Yeah. Sorry, what?
Which one? Problem 2 or problem 1? I went through a lot of problem 1 already, right?
Yeah.
So problem 2, so one key is you have to create the elements first, and then apply loading to the element node. So you make sure it's enough to jump to find the elements, because you have the percentage node, which is loading, which should be on the element nodes. So you can create an surface with x, y, z, or a solid with x, y, z, and then you apply properties, and then mesh, and then after you have elements, you can apply the notification. Because you can apply final condition earlier, or you can apply final condition notification after you have a mesh.
Yeah. And that might be going to one of the things that I was mentioning here. When you're applying loads and stuff like that, and you do your select application region, make sure that you click the right thing. Like for example, if you want to apply it to just one node, you can select this point right here, and that will let you apply it to just a particular node. So that might be going with, I'm not exactly sure what the problem. Yeah, I just don't remember from like 2 semesters ago. Yeah. So yeah, but this might actually help you get to what you want to do. Is by selecting a point or a vertex, you'll actually be able to apply it to where you want to apply it. Okay. All right. You good? All right. Cool. Yeah, Eric is going to talk about some of the. So Eric, on Friday, he's going to talk to you about like actually building a model, some of the tools in Patran you have for like shaping things and stuff like that, and making it look nice and whatever, fillets and stuff like that. So he's going to go through that, and he's also going to do some general like, hey, here's a tip for something or something like that. So if you guys want to build stuff in Patran, definitely be here on Friday, because SolidWorks is good. You can make SolidWorks and you can make models in SolidWorks, but if you know how to make models in Patran, it'll save you an extra step. And there'll be less likely a units or whatever problem. So Friday will be good for that.
Thank you.
All right.